Okay, here we have a quadrilateral, which is a rectangle. That's awesome. So what can I say about this figure? Well, we know for sure that the diagonals are congruent, right? So the diagonals bisect at a midpoint, and it's going to split the segment into two congruent parts. So what does that mean for this segment and this segment here? Well, this is the midpoint of DF. So I'm going to put one tick mark here and one tick mark here. And the reason why I don't put two is because the diagonals of a rectangle are congruent. So FD, we know FD is 3x minus 7. This is 3x minus 7, and EG is x plus 5. What you want to go ahead and do is set these things equal to each other, and you're going to solve for x and then plug it in to EG. Okay, so 3x minus 7 is equal to x plus 5. 2x is equal to 12. X is equal to 6. So what does this mean? Well, I know x is equal to 6, so I'm going to plug it in. So it's 6 plus 5. That's going to give me 11. EG is 11. Okay? If the measure angle sorry, that's not EFD. EFD is 2x minus 3. Okay, and DFG is x plus 12. Find the measure angle EFD. Okay, so know that we were dealing with this angle and we were dealing with this angle. And since this is a rectangle, each angle is 90 degrees. Once again, we are dealing with, I'm going to use a different highlighter. We're dealing with this angle, and we are also dealing with this angle. And know that these two adjacent angles, they equal 90 degrees. So you want to basically take these two things, add them up, and set them equal to 90. So it's 2x minus 3 plus x plus 12 equals 90. You're going to go ahead and solve for x. And once you solve for x, you're going to plug it in and figure out what the measure angle. You're going to figure out what the measure angle EFD is. Okay? Oh boy, here we go. We have to deal with this, graph each quadrilateral with the given vertices, determine whether the figure is a rectangle. Justify answer using the indicated formula. We're going to be using strictly the distance formula, which is D equals the square root of x sub 1 minus x sub 2, the quantity squared, plus y sub 1 minus y sub 2, the quantity squared. And let's go ahead and plot the points. 4, 3 is A. 4, negative 2 is B. Negative 4, negative 2, that's C. And then lastly, D is negative 4, 3. So then we will connect the dots. And we gotta verify. This looks like a rectangle to me, right? But we gotta verify using the distance formula. And, well, we have to understand, what do we have to do? We can't just necessarily start with just the diagonals and only diagonals. We have to prove. We gotta prove that these opposite sides, we gotta prove that the opposite sides are congruent. Okay? And what you want to go ahead and do is you're going to find the distance of this and this. So you're going to find the distance between DA, and you're going to use that formula. okay? And you're going to go ahead and find the distance between CB using that same formula, okay? And if those two things are congruent, great, you got one pair of congruent sides. Now, you got to show that these sides here are congruent. So you're going to use the distance form between DC, whatever that is, and you're going to compare that to the distance of AB, okay? And if those sides are congruent, great, you got two pairs of congruent sides. That is going to be great. That could be a rectangle, but you got to do one more. You got to give it the cherry on top, and that is showing whether or not the diagonals are congruent. So you need, prove that the diagonals are congruent. So the distance between BC, the distance between DB and the distance between AC, okay? And if those diagonals are congruent, okay, if the opposite sides are congruent and the diagonals are congruent, then we can say then it is a rectangle, okay? So that's what you're gonna go ahead and do. Number 14, if ZY is 2x plus 3 and WX is x plus 4, find WX in quadrilateral WXYZ is a rectangle. So, where's ZY? ZY, WX, it's a rectangle. So, these opposite sides must be congruent. It's a parallelogram. A rectangle is a parallelogram where opposite sides are congruent, opposite angles are congruent. So if ZY is 2x plus 3 and WX is x plus 4, what are you going to do with these two expressions here? Okay, you're going to find the x and then you're going to plug it in. So what is WX? The next one is quadrilateral ABCD. It's a rectangle, and find each measure if measure angle 2 is 40. Okay, so the measure angle 2 is 40 degrees. Okay? And, well, with a rectangle, the diagonals do not bisect angles. That only applies to rhombis and squares, okay? So if I really want to find the measure angle 1, but y'all, you know that these angles here are 90 degrees each, so we can go ahead and just do the math. So this is saying, this 40 degrees is part of that 90. What the heck is that? What is that left over? Well, this is 50 degrees. That has to be, because what? 50 plus 40 is equal to 90, right? So the measure angle 1 is 50 degrees, and then the measure angle 3, well, look at this. It's a rectangle, right? And it's a parallelogram, so I have these parallel lines. And they are cut by a transversal. And if this here is 40 degrees, then this is 40 degrees by alternate interior angles. Okay? So then you can go ahead and figure out the measure angle. What is it? Measure angle 8? Yeah, you can go ahead and figure out what the measure angle 8 is. So we know this is 40. And, so this is 50, and this has to be 40. So this is saying, okay, it's a triangle. 40, 40, and then this is 40 degrees, 40 degrees, and this is measure angle 8. So you can probably figure out what measure angle 8 is using the sum of interior angles of a triangle theorem. All right. Let's see. I just want to take a look at all this. Quadrilateral ABCD is a rhombus. Find each value or measure. Know that with a rhombus, the diagonals are perpendicular and they bisect angles. Okay, so if AB is 14, what is BC? So what is BC? I don't know what BC is. So let's write this. Let BC equals X. I'll call that X. And okay. What do I do if AB is 14, what is BC? Well, this is what I'm looking for, and I don't even know why. It kind of like, my brain just like froze. Y'all, a rhombus, all the sides are congruent. All the sides are congruent, so this has to be 14. What am I doing? Why am I being so extra? That's 14. Okay, so let's go ahead and, oh, you know what? You have to redraw the figure, or maybe you have to use the same figure. That's annoying. That's annoying, but that's okay. And then BCD, that's 54. So this is 54 degrees. Okay, remember the diagonals bisect angles. So how long is the measure angle? BAC. So how long is BAC? Okay, so if you know what this angle is, you should know what this angle here is too. Okay. AP is 3x minus 1. So AP is 3x minus 1. And PC is x plus 9. Well, y'all, remember, this is a parallelogram. A rhombus is a special type of parallelogram. So the diagonals bisect each other at a midpoint, and it's going to split those segments into two congruent parts. So if AP is 3x minus 1, and PC is x plus 9, you can go ahead and figure out what to do with those tick marks that we just drew. And then go ahead, once you solve for x, plug it into AC. Okay, find AC, which is this whole thing here. So that means you're gonna plug it in here, and you're gonna add them up. Or you're gonna add these up because that's AC. PD, okay, so DB is 2x minus 4. And PB is 2x minus 9. Okay, well, you need pretty much 2 of these to give you that. Okay, so you can go ahead and figure that out. And this is pretty similar to one of the problems on the notes. And then this one here, measure angle ABC is 2x minus 7. And measure angle BCD is 2x plus 3. Find measure angle DAB. So ABC is 2x minus 7, and BCD is 2x plus 3. Find DAB. Okay, so you have to understand this. Look, you have to understand that the consecutive angles are supplementary, because it is a parallelogram, right? One of the properties of a parallelogram is that consecutive sides are supplementary. So I add these angles up. And that should equal to 180 degrees. So here is ABC, and here is BCD. Take these, add them, equal 180, and then plug it in. Okay? Number 9, if AP is 3x minus 1, here's AP, that's 3x minus 1, and then PC is x plus 9. Okay, that's really, really easy. You can figure that out. Number 12, DPC is 3x minus 15. Find x. Well, these diagonals are perpendicular to each other, so you can set that equal to whatever the value of that square is here. Okay? I'll be right back. Alright. So, the next thing I want to go ahead and do is look at this one. A, B, C, D is a rhombus if PB is 12 and AB is 15. Okay, so let me go ahead and draw this. So PB is 12 and then AB is 15. Find ABD. Oh, wait. If PB is 12, AB is 15, and the measure angle ABD is 24 degrees. Okay, so this is 24 degrees. Find each measure. My goal here is to figure out AP. Great, so these diagonals intersect at a 90-degree angle. Okay, so then if I redraw this triangle, this is 12, this is 15. Okay, and my goal here is to figure out what this is here. So this looks like I gotta use the Pythagorean theorem. So that would be a squared plus b squared equals c squared. So a squared plus b squared equals c squared. And we actually know what c is. It's actually 15. How do we know that's c? Well, it's across from the 90-degree angle. So this is the hypotenuse. So I put 15 squared here. And then a can either be this or this. It doesn't really matter. I'll just call it a squared plus 12 squared. And then I'm going to minus 12 squared on both sides. So that's going to give me a squared equals 15 squared minus 12 squared. Take the square root. And that should give you... what's that? 15 squared minus... what is the other one? 15 squared minus 12 squared. And that's going to give me 9. So A is 9. So that is how long AP is. So this is how long AP is. And then the measure angle BDA. So BDA. How long is that angle? Okay, well, we know that these angles, opposite angles are congruent. Yes? And this whole angle here should be, you know, twice as this angle. Okay? So that means that these angles are congruent. Even the little ones right here are congruent to the little ones over here. So if this is 24, this has to be 24. And this is 24, and that's 24. So that angle is 24 degrees. And then CP, what's CP? CP, okay. So you just need to know that these diagonals intersect at a midpoint and splits the segment into two congruent parts, so you can figure out what that is. And then ACB, great. So you know that this is 24, right? You know this is 24, so this has to be 24. So this is 48, right? So to figure out what ACB is, well, you need to figure out what the angle C, you need to figure out what the measure angle C is. So I'm trying to say is the measure angle B is 42. So this angle here is 42, right? You need to figure out how long this angle is first. And you're going to do 180 minus 42, which is, what is 180 minus 42? Because golly, I have no idea. That's 138. Okay, so if this angle here is 138, you're trying to figure out what measure angle ACB is. Okay, so you can go ahead and do that on your own. And then this is a square. WT is 3. ZX Where's ZX? ZX is here. Okay? And we know that the diagonals of a square, one of the properties of a square, the diagonals are congruent. So you can probably figure that out, right? 28 xy. What's xy? I need to figure out what this is. Okay? So you're going to have to use Pythagorean theorem for that one. That's for sure. Once you figure out what this is and this is, you can go ahead and, do the Pythagorean theorem. Sorry, I'm trying to think here. W T Z. Yep, that's easy. Remember, what do the diagonals do? They intersect at how many degrees? And then the measure angle WYX. WYX. Okay, so it's really talking about this angle. And if this is 90 degrees, how long is that angle? Okay? And then, oh my goodness, holy moly. What you want to go ahead and do is, I'm not going to write anything down, but you're going to go ahead and do, number one, plot the points. And then number two, you need to determine whether, I'm trying to think. So this is a parallelogram. You can assume that this is a parallelogram. Okay, you're gonna plot the points and all that sort of thing. What you want to go ahead and do is determine whether that parallelogram has, you need to check the I'm trying to think. You need to check the you need to check the slope. You need to check the slope, and you need to check whether the diagonals are perpendicular or not. Basically, it's that same idea with the notes that correlate with the homework assignment, which should be this one right here. Okay, so number one, find the slopes of the diagonals. Number two, determine if the diagonals are congruent. And then determine if it's a rhombus, rectangle, square based on your findings. That is what you're going to be doing for that problem. Okay? So, there you have it. I am now going to bed. Have a good night.